All right, good morning, class, or good afternoon, or good evening, depending on when you're watching this. Today we're going to review parent graphs from Algebra 1 and Algebra 2. So this is super important going forward in our next unit, but I feel like you guys are smart enough that you can watch this video and you don't have to waste class time going over everything in detail. So first thing, we need to know the basic graph. What does the absolute value of x look like? You guys will probably tell me it looks like a V, which is amazing, but where does that V live? What are the actual points? So the first parent graph is absolute value, and it's whenever you have the lines, obviously, in your function. Absolute value is the distance from 0, so you're looking for all positive answers for your y's. So if I plug 0 into the function for x, absolute value of 0 is 0. So your original point is located at 0, 0 on the board. If you plug in 1 to your formula for x, the absolute value of 1 is just 1, so 1, 1 is a point. If I plug 2 in for x, the absolute value of 2 is 2. So 2, 2 is another point. If you plug in -1 for x, the absolute value of -1 is 1. So -1, 1 will be a point right there. And I think you can see the pattern. -2, 2 is a point right here. So this is the V that you get for your parent function of absolute value of x. Now, later we're going to talk about transformations, like moving that up or moving it down, left or right. You could stretch it vertically, horizontally, a whole bunch of words, and reflection. Oh my gosh. So there are so many words that we're going to talk about later of what you can do to this graph. But for right now, I just want you to know what the basic parent function would be. So your basic parent function for x squared, this got some of you on your first test. This is called a quadratic or a parabola. The only type of function that can be quadratic is a square. Not 4, not 6, not 8, a square. Okay, so if you plug all these numbers in, 0 squared is 0. So 0, 0 is a point. 1 squared is 1. So 1, 1 is a point. 2 squared is 4. So that's where this graph gets to be a little bit different. You go out to 2, up 1, 2, 3, 4, and put a point. The reason that grows exponentially is because there's an exponent there. Okay, then be careful. When you square -1, you always get, I heard you say it, not really, a positive. So -1, positive 1 is another point. -2 squared, make sure you use parentheses, is 4. So -2, 4 is another point. And those are the points that you need to know. Okay, you guys need to know what these graphs look like without plugging numbers in the future. So for parabola, it starts at 0, 0, then it goes left 1, up 1, left 2, up 4, and it's the same on the right. Right 1, up 1, right 2, up 4. Those are the points that you need to know, and you could continue to find more points if you wanted to. You could find out that 3 squared is 9, so there's another point all the way up here somewhere. Moving. Another parent graph that you should recognize is the square root of x. Oh wait, let's go back. Totally forgot domain and range of these functions. So I got too excited to do the square root of x. Domain of this function, remember domain is your x's and range is your y's. So if you look left and look right on this graph, it is going forever. So your domain is negative infinity to positive infinity with parentheses. Remember, you can never have brackets on infinity. And then your range, you want to look at your y values. So this one you're looking down and you're looking up. So the bottom of that graph is located where? The very bottom of that graph is here. What y value is that? You're right, that's totally 0. There's a closed circle on 0, so you use a bracket. And then that graph is going up to positive infinity. So your range is 0 to infinity for absolute values. Hey guys, doesn't the quadratic kind of look the same? The quadratic is just more of a curve. It doesn't have two straight lines, but it's still, for your x's, it's going left forever and right forever. So that's negative infinity to infinity. And your range, the bottom of that graph is located at 0, and then it goes up forever. So it's going up to positive. Okay, let's now let me do the square root graph. I'm so excited. What's the square root of 0? 0, good job. So the name of that graph is square root. There's no fancy name for it. And we know it starts at the origin. So far, if you've noticed, they all start at 0, 0. Then the square root of 1 is 1. So 1, 1 is a point. Again, all three so far have a point at 1, 1. Square root of 4 is 2. 2, 4, 1, 2. So guys, doesn't it kind of make sense that the points on your square root graph are opposite the points on your squared graph? Yeah, because they're inverses. They're opposite of each other. So in your quadratic, 2 was paired with 4. And now in your square root, 4 is paired with 2. They have switched locations. And let me get this red circle out of here. So another important point on your square root graph, the square root of 9 is 3. 1, 2, 3, 8, 9, 3. So your square root graph goes like this because what's the square root of negative 1? Yeah, it's I. It's imaginary. You can't do it. You can't see it. It's not on your graph. Okay, so this is your final square root graph. That's it. Only that portion on the top. You can never have anything on the bottom because you can never take the square root of a negative number. Okay, so for domain for this, it doesn't actually go left and right forever. Where does that graph start? So if you're looking left to right for your x's, you look all the way to the left, that graph is starting at 0 and going to infinity. The range of that graph is still the same, and also the bottom of that graph is 0, and it's going up to positive infinity. So those are a little bit different. Moving on to the next one, x to the third power. You should know that one's name is cubic. So 0 to the third is still 0. So guys, again, 0, 0 is a point on all of my parent functions. Then 1 to the third is 1. 1, 1 is a point on all of my parent functions. 2 to the third is 8. Be careful, don't say 6. So 2, 2, 3, 4, 5, 6, 7, 8 others. Negative 1 to the third. Be careful. Negative 1 times negative 1, positive 1 times negative 1. Again, gives you a negative 1. So when you square things, they turn positive. But when you cube them, they stay negative. So negative 1 is a point. Negative 2 to the third is negative 8. So like this, you knew that this graph looked like this already. We've done this before. What is that called on the x-axis right there? Ooh, fun fact from the first unit. That is a point of inflection. Okay, so that x to the third power graph has a point of inflection. Your domain, this is going left and right forever. It's also going up and down forever. So your domain and range are both all infinities. Now, cube root function should be similar. Okay, we're doing the opposite, the inverse. Okay, so the cube root of 0 is still 0, guys. 0, 0 is still 1. The cube root of 1 is 1. The cube root of 8 is 2. 1, 2, 3, 4, 5, 6, 7, 8, and 2. Okay, now you can take the cube root of a negative, just like you can cube a negative up here. You can totally take the cube root of a negative 1. The cube root of negative 1 is negative 1. And the cube root of negative 8 is negative 2. So out here. And your graph, sorry guys. Your graph looks very similar to the cubic function. It's just on its side here. Okay, now be careful. That is one of the most missed questions in any unit of pre-calculus or beyond, is the difference between a cube root and a cubic graph up here. So be very careful. Cubic should be standing up tall. Cube root should be laying down flat. Okay, your domain and range both are still negative infinity to positive infinity. It's going left and right forever. And those graphs are slowly going down and slowly going up forever. The next one, you should totally know how to do this. This should haunt your dreams. This is a rational function. There's your vertical asymptote here. Yeah, you set the bottom equal to 0. So this is my VA. It doesn't actually have a point there. Okay, that's a vertical asymptote. You do that. Then, to get the x-intercept in the unit we're in, you'd set the top equal to 0. 1 doesn't equal 0, so there is no x-intercept, which is all stuff you're going to be doing really well on your test before you watch these notes. I'm sure you got all of that right. So that was last unit. Now, for parent functions, I want to plug it in and see what it looks like. Oh, wait, this is totally bottom heavy. So my horizontal asymptote is yo. Just like Kardashian, that's so cool. Okay, so this is my horizontal asymptote. Now, let's plug numbers in. So if I'm substituting for x, this would say 1 over 1, which is just, oh my god, look at that 1 is again. Substituting for x, this is 1 over 2. So 2, 1/2. Substituting for x, 1 over negative 1 is negative 1. So negative 1 and negative 1's a point. If you substitute for x, 1 over negative 2 is negative 1/2. So negative 2, negative 1. Okay, I'm going to skip these because you totally know what this graph looks like already. Has the swoopy guys. What's your domain? Yeah, you find it from the holes in the vertical asymptote. Well, I only have a vertical asymptote, nothing canceled. So my domain is negative infinity to 0, 0 to infinity. My range is going to be the same, which we didn't talk about in this unit, but if you look at the graph, you go from negative infinity to your horizontal asymptote, which is at 0, and then you pick back up and you go up to positive. Okay, my asymptotes are x equals 0 for my vertical, and yo for my horizontal. There's no sign. Remember, if you have a horizontal, moving on. Ooh, transformation. So those are the graphs that are super important right now. We will learn more graphs in this upcoming unit, which is why it's important for you to know basically what those graphs look like. Okay, so keep that paper, study it, and if I say absolute value, you should know it's a V. Quadratic, parabola. Cubic, the standing up squiggle. Cube root, the laying down squiggle. Rational is the swoopy guys. And then square root is the one that I skipped. It is the one that starts at 0 and goes off to infinity. Okay, speaking of transformations, so anytime you have a formula, like let's say you have y equals x, that's the parent. There's no numbers, it's basic, it's generic, that is the parent function. So a vertical shift is anybody that says f of x plus c. Okay, actually I think they use the letter d, so let's use the letter d. So plus d at the back. So a vertical shift would be like y equals x plus 4. Okay? If I have a plus 4 at the back on a line, and anything else that would move it up, if it's positive, and if it's negative, it's going to move it down. So for my examples, I'll just write the description in the example box. I would write y equals x, would change to y equals x plus 4. Could be minus 4 too, so you write plus 4 times. If there's a plus at the back, it moves up. If there's a plus at the back, or a minus at the back, it moves it down. Horizontal shift. Okay, so horizontal is your x-axis. So horizontal is always your x-axis right here. That's a horizontal line. So anything that's a horizontal shift is actually anything that has to do with x is opposite what you would normally think. So if I wrote, this would be f of x plus or minus c. Okay, so if you have, let's say, x plus 4 squared. Okay, let me write that in the example box. X plus 4 squared. What do you know that graph is? What does the squared tell you? Okay, the squared tells you it's quadratic, which means it's a parabola. And the plus 4 should look familiar from Algebra 2. If it's inside the parentheses, it's actually opposite. So plus is left 4. And let's say it said x minus 4 squared. If you have a minus sign, that means it moves to the right 4. So anything with x is actually opposite what you think it would be. Okay, vertical, stretch, or compression. So this is also vertical. This has to do with your y values, because y is your up and down. So vertical and y's always live on the outside. So see how that plus d was at the back? It was outside the parenthesis. If you have a vertical stretch or compression, that means that it's going to be a times f of x. So that a, that number is going to be on the outside. So it would look something like this if you had y equals 2x. Okay, that would be a vertical stretch. So a number that is greater than 1 is a stretch. Anything that's a fraction that's less than 1, okay, so like 2/3, 1/2, anything that's a fraction less than 1 is going to be a compression. So fractions are compressions, and numbers that are greater than 1 are stretches. Okay, so this is a stretch. A compression would be like 1/2. Okay, any number that's out in front is a vertical stretch or compression. Horizontal stretch or compression. Guys, if it's horizontal, it has to do with your x-axis, because that's your horizontal axis. Okay, horizontal again is on your x-axis. Anything that says horizontal has to be on the inside of parentheses. So your horizontal stretch or compression would look like that. Okay, B would be a number, it could be 2, it could be 1/2, it could be a million. Okay, anything that goes right here could be a number. Now, it has to be inside the parentheses, and it's still opposite. So up here, even though left on your x-axis is negative, we have a plus sign. And even though right on your x-axis is positive, we have a minus sign. So anything that says horizontal is exactly the opposite of what you would think. Okay, so if I had y equals, let's do 2x squared, that's actually not a stretch, that's a compression. So a number greater than 1 is a compression, and a number less than 1, so if I do 1/2, x squared is going to be a stretch. So any fraction less than 1 is going to be a stretch. And we're going to do some examples in class together that with numbers that will prove this to you. So if you don't believe me right now, it's okay. I will promise I will show you why in class when everybody's here, so you guys can ask me questions. So right now, number greater than 1 is a compression, number less than 1 is a stretch. Okay, again, guys, this says vertical. So vertical is outside the parentheses. So that's a vertical reflection would have a negative all the way in the front of the function. So it would be like negative x plus, ooh, use a square root, negative square root x. Okay, that is a vertical reflection because it's outside the parentheses. So maybe I would write that anything that's vertical is outside, and anything that's horizontal is inside the parentheses. So my vertical reflection, guys, it reflects it vertically. So that means if my graph was up at the top here, it's going to end up down at the bottom. Okay, so vertical reflection moves it from up to down, which makes sense because that's the vertical, those are the vertical directions. So it flips over the x-axis, which is what confuses people. Okay, guys, if it's vertical, it has to move from up to down. It's flipping over. You would fold it over that x-axis, so it flips over the x-axis, which totally confuses people sometimes. Horizontal, okay, so that's anything that's inside the parentheses, so it would be like f of negative x. So anything that like that, if I use my square root function, it would be on the inside, and that flips it horizontally. So that means it's, if you have your xy axis and your graph is back here, it's going to swing side to side, not up and down. Horizontal is side to side. So that new graph would be on the right. Okay, so it flips over the y axis. So this is the basic formula with all the transformations for a quadratic because it has a square. So on the outside, remember, anything outside has to be vertical. So I know this A is vertical and this D is vertical. A is a vertical stretch or compression. D is a vertical shift up and down. Okay, B and C are inside, so they both have to be some kind of horizontal thing. So B is a horizontal stretch or compression. C is a shift up or down because it's plus or minus. I'm going to finish the rest of this page right now on the notes, and then you can try the questions on the following page for practice. I'll tell you what numbers I'm going to finish. So, describe the transformation using correct vocabulary. So this says the graph of a quadratic. Okay, so I know that's going to be something squared. I leave space because I don't know if there's a horizontal shift or anything. It's got to be translated 3 units down. That's a vertical, so that's got to be outside. Down is minus. 2 units to the left is horizontal, so that has to be inside the parentheses. And this is opposite what you think. So in life, left is negative, but here, left is positive. Okay, so x plus 2 squared. Number 2, the graph of a cubic function. Okay, so it's got to say y equals. I've got to have to the third power. Translated 3 units up. So up is vertical on the outside. 5 units right. Okay, 5 units to the right. It is opposite what you think. So in life, right is positive, but here it's going to be negative. I don't know why my y is so far away. Can move that over, and that's your answer. This one says the graph of a square root function. So y equals square root x. Ooh, stretched horizontally by a factor of 3. Okay, so this one is going to have, I need some space in front of my x. If I'm stretched by a factor of 3, it has to be opposite what you think. So that has to say 1/3 x, because a stretch has to be a fraction on the inside. And then it's got to be translated 6 units up. Guys, up is vertical. That has to be outside of your square root. So if you write plus 6 at the back, that's beautiful. If you put your plus 6 underneath the square root, that's in, like being inside the parentheses. That's going to be horizontal, and it's going to change to a minus sign. So it's actually going to move left 6. That's not what we want. We want it to be up 6. So he's got to chill outside the square root at the back. Okay, the graph of a rational. A rational is a fraction. So it's got to be y equals 1 over x. Stretched vertically by a factor of 4. Vertical is on the outside, so you can put a 4 on the outside of your parentheses. But guys, what's 4 times 1 over x? It would be the same as 4 over x, because you do 4 times 1, bring the x along. Okay, so that's stretched vertically by a factor of 4, and then it's translated 10 units to the right. Usually that has to live inside the parentheses, but I don't have any parentheses here. Well, I do. They're right here. So if it's got to go right, right is usually positive. I'm going to change it to a negative. 10, that's got to live on the bottom of that fraction with your x. If it's horizontally shifted, then it has to live with the horizontal axis letter, which is x. Okay, so y equals 4 over x minus 10 is the correct answer for that question. Okay, number 5, the graph of a cube root function. Cube root is the sideways one. Don't mess that one up. It's not cubic. So y equals cube root, translated 1 unit down, so minus 1, and 4 to the right. Okay, right is usually positive. I changed it to a negative. So it will live inside the cube root, and that is a horizontal shift. The graph of an absolute value function. So y equals absolute value of x, and I'll leave some space. Translated 5 units left. Left is usually negative, change to positive. And vertically compressed by a factor of 1/3. Guys, vertical is exactly what you think it is. Nothing is opposite with vertical. So because it's vertically compressed by a factor of 1/3, you just put a 1/3 outside because it says vertical. It has to be outside of your absolute value, or in this case, well, or your parentheses if you have parentheses. Finally, number 7, the graph of the square root function horizontally compressed by a factor of 1/7. Okay, well, square root horizontally compressed by a factor of 1/7. Okay, that's going to be opposite what you think it is. So what is the opposite of 1/7? Yeah, 7. Good. So there's a 7 on the inside. And stretched vertically by a factor of 4. Guys, vertically doesn't change anything. So if you are stretched vertically by a factor of 4, there's a 4 on the outside of your 4. Okay, so what I want you guys to try before you come to class is 8 through 12. And then you can stop here and we will graph all the transformations together because I know we're going to need help with that and I want to make sure you get it right. So please mark on this paper anywhere that you're confused or anywhere that you have questions so I can go over it in class. And I hope you have a wonderful rest of your day.